Hey, I'm Jason from Wild Earth, and I'm here to talk about stops in photography. Today I'm going to explain to you what a stop is and what it means for lenses. You may have heard that an f4 lens is one stop faster than an f5.6 lens. Well, what does that mean? That means that the f4 lens lets in twice as much light as the f5.6 lens, assuming of course they're set at their maximum apertures. In general, stops measure the difference in strength between two signals. So a signal that is x stops stronger than another signal means that it's 2 to the power of x times stronger. Stops can also be used to talk about exposure. So this image of a ruby-throated hummingbird that I took a few weeks ago was 1.875 stops underexposed. Yes, I know I sometimes underexpose my images. It's not on purpose. But that means that if this image had 2 to the power of 1.875 or about 3.67 times as much light, then this image would have been properly exposed. But how do stops relate to the f number of a lens? So you might have seen lenses that are f4 lenses or f2.8 lenses or even f.95 lenses. Wish I had one of those. But you may have seen these different f numbers on a lens. What do those f numbers mean? Well, the f number of a lens is the number you get when you take the focal length of a lens and you divide it by the diameter of the entrance pupil. So for example, because this lens here is an f2.8 lens, it means if you take 50, the focal length, and you divide it by the diameter of the entrance pupil, you get 2.8. So what does that mean in terms of the amount of light coming into a lens? Well, because the f number is inversely proportional to the diameter of the entrance pupil, and the square of that diameter is proportional to the area, and the area is proportional to the amount of light coming in the lens, the inverse square of the f number is proportional to the amount of light coming into the lens. So what does that mean in practice? Well, for example, if you have a lens that is f1, in order to find the f number of a lens that is twice as slow or lets in 2 times less light than an f1 lens, you have to multiply 1 by the square root of 2. So we can list these numbers in a row. 1, the square root of 2, 2 times the square root of 2, 4 times the square root of 2, 8, etc. And we get this sequence. And if we approximate it, we get the familiar f numbers that you often see on lenses. You get 1, 1.4, 2, 2.8, 4, 5.6, 8, etc. By the way, I'd like to say that the square root of 2 is irrational. Unfortunately, it's not as irrational as most of the arguments that occur on the internet about photography. Now let's do two examples to calculate the difference between two lenses in terms of stops. Here, as I showed you earlier, is the Venus-Laowa 2x macro. It's an f2.8 lens. And here on this camera is the Pentax 50mm f1.7 lens. f2.8, f1.7. So what is the difference in stops between these two lenses? Well, in order to calculate that, you take the 2.8, divide it by the 1.7, and square it. So 2.8 divided by 1.7 squared is about 2.713. So the Pentax f1.7 lens lets in about 2.713 times as much light as the f2.8 lens per unit time. So what is that in terms of stops? Well, we said that x stops difference between two signals means that one signal is 2 to the power of x times stronger than another signal. So we have the equation 2 to the power of x equals 2.713. Now, in order to solve this equation, you just simply take the base 2 logarithm of 2.713, and you get 1.44. So the Pentax 50mm f1.7 lens is 1.44 stops faster than the Venus-Laowa f2.8 lens. Let's do one more example. Nikon recently came out with the 400mm f4.5 lens and the rather expensive 400mm f2.8 lens. What is the difference in stops between these two lenses? Again, to make this calculation, we take 4.5 and divide it by 2.8, square it, and then take the base 2 logarithm of that number. When we do this, we find that the difference in stops between the 400mm f4.5 lens and 400mm f2.8 lens is 1.37 stops. So there you have it. In order to calculate the difference in stops between two lenses, just take the f number of one, divide it by the f number of the other, square it, and take the base 2 logarithm of that number. And that will tell you the difference in stops between those two lenses. So I hope you enjoyed this explanation of stops. If you have any questions, please leave them in the comments below. and happy shooting.